Welcome back to Advanced Skills Learning. Today we'll cover the missing layer in vector search: metadata filtering, the practical technique that turns noisy retrieval into trusted RAG answers by constraining results using source, document type, and recency. If you've ever built retrieval and still got inconsistent answers, this is one of the fastest fixes, because better retrieval produces better context, and better context produces better answers. Here's the key idea to anchor everything: RAG is only as good as retrieval. If your top results are noisy or off-topic, the model will still answer confidently, just with the wrong evidence. In production, a lot of hallucinations are actually retrieval failures. The right document wasn't fetched, it was ranked too low, or it was buried under irrelevant content. Metadata filtering reduces that noise early, before ranking even begins. So what exactly is metadata? Metadata is structured information attached to your documents or chunks, fields like source or repository, document type, created date or updated date, product area, environment, region, team ownership, and tags. Embeddings capture meaning, but metadata captures facts about the document itself. Filtering uses those fields to narrow down the search space, and ranking rules can use metadata to prioritize authoritative sources. Quick check: 2 seconds. Which filter most directly helps avoid outdated answers? A. Doc type. B. Updated date or timestamp. C. Chunk length. Keep your guess in mind. The answer is B. Updated date or timestamp. Recency is often the simplest way to prevent old guidance from outranking the current truth. Now let's talk about why vector-only retrieval can miss, even when embeddings are good. Semantic similarity can match content from the wrong domain, something that sounds similar but doesn't apply. Older documents can be semantically similar and still outrank newer, correct policies. And similar wording does not guarantee correct context. Metadata gives you boundaries, so you search for meaning inside the right slice of your content. The clean mental model is: filter first, then rank. You apply metadata filters to reduce the candidate set. Then you run vector similarity search within that subset and take your top K results. And if you want even higher precision, you can optionally re-rank the top results with a re-ranker model or a scoring rule. This order, filter first, improves relevance and often reduces latency and cost because you're searching a smaller space. Most metadata filters fall into 3 common types: equality filters, like doc type equals runbook; range filters, like updated date within the last 12 months; and set membership filters, like product area in a list of allowed products. These are simple, explainable, and they map well to how people think about narrowing results. If you add only a few metadata fields to start, focus on the must-haves: source or repository, document type, and created or updated timestamps. Source reduces cross-domain noise, doc type lets you separate official guidance from informal notes, and timestamps reduce outdated results. These 3 fields alone can improve retrieval quality more than most embedding tweaks. Metadata filtering becomes even more powerful when you combine it with hybrid retrieval. First filter by metadata, then retrieve using both keyword and vector search, and merge results. That gives you strong coverage across both exact match queries, like error codes and identifiers, and semantic queries, like how-to and explanation questions. Routing rules can adjust weights based on what the user asked. How do you choose filters from the user query? Extract constraints from the question: product, region, timeframe, environment, document type, or source. If the user doesn't specify anything, apply safe defaults, like prioritizing authoritative doc types and recent content. And when the question is ambiguous, ask one targeted follow-up that unlocks retrieval, instead of guessing. Now the most common pitfalls: overfiltering and underfiltering. If you overfilter, you might accidentally remove the one correct document. If you underfilter, you let noise flood retrieval and waste top K slots. A practical approach is to start slightly broad, observe what shows up, then tighten based on what you learn from results and evaluation. Quick check: 2 seconds. Where should metadata filtering happen in retrieval? A. After the model answers. B. Before vector ranking. C. Only in the prompt. Keep your guess. The answer is B. Before vector ranking. Filtering is a retrieval stage control. It narrows the candidate set so ranking and generation start with better evidence. Metadata doesn't stop at filtering, it can also shape ranking. Even within a filtered set, you can boost authoritative doc types like policies and runbooks above informal notes, prefer newer documents when questions are operational or time-sensitive, and penalize sources you know are low quality. This is how you encode trust into your retrieval system in a simple, explainable way. And finally, don't ship without measuring. Track retrieval hit rate, whether the right document appears in the top results. Track groundedness, whether answers match the retrieved chunks. Track latency and token cost, because filtering usually lowers both by reducing irrelevant context. Metadata filtering tends to improve relevance, consistency, speed, and cost all at once, which is why it's such a strong return on investment move. Key takeaways: filter first, then rank. Start with source, doc type, and timestamps. Avoid overfiltering, reduce noise, and tune with measurement. When retrieval improves, the entire RAG system becomes more reliable. That is why it is considered as the fastest way to boost RAG relevance, cut cost, and reduce hallucinations. Thanks for watching Advanced Skills Learning. If you found this useful, please like the video and subscribe for more GenAI Explained videos, practical architecture patterns, and quick quizzes.